Hello everybody, in this lesson I will discuss logarithms as well as the logarithmic function. A logarithm is a way of writing an exponential equation with the exponent as the subject of the equation. When I give you x is equal to b to the y, where b is greater than 0 and b is not equal to 1. b is the base and y is the exponent. Then we say the number equals base to the exponent. Now when we convert this exponential equation into a logarithmic equation, this is what we're going to do. You write log, and then the base of the exponent becomes the base of the log. The number on its own stands here with the log, and the exponent gets expelled and it stands on its own on the other side. It becomes the subject of the formula. Let's write the following in logarithmic form. If I give you 3 to the 4 is equal to 81, then you write log. The base of the exponent is the base of the log. The number on its own will stand with the log, and the exponent on its own equals to 4. The next one, 2 to the 5 is equal to 32. You write log. The base of the exponent is the base of the log. The number on its own will stand with the log, and the exponent will stand on its own, becomes the subject of the formula. And then the last one, a to the b is equal to c. You write log. The base of the exponent is the base of the log. The number on its own will stand with the log, and the exponent on its own on the other side becomes the subject of the formula. Then let's do it the other way around. Let's write the following in exponential form. When I give you log 8 is equal to 3, then you can write it as the base of the log becomes the base of the exponent. The 3 will become the exponent, and the number with the log will stand on its own. Another one, log 3y is equal to x. We say the base of the log becomes the base of the exponent. The y will go and stand on its own, and the x becomes the exponent, the one on its own. If I give you log AC is equal to b, then you write it as the base of the exponent is the base of the log. The b, the number on its own, becomes the exponent, and the c, the number with the log, will go and stand on its own. Solve for x in. 3 to the x is equal to 5. So it's very clear that you can't solve that one. So what we do is we're going to write it in log form. So we write log. The base of the exponent becomes the base of the log. The number on its own will go and stand with the log, and the exponent becomes the subject of the formula. Now, how to deal with that one? You will use your calculator. So somewhere on your calculator, you will look for this button, the log button, but the one that's got 2 little squares there. That's the one that you're going to use. And then when you click on that button, in the basis place, you punch in the 3, and in the numbers place, you punch in the 5, equals, and you get your answer, 1,46. Now we're going to investigate the inverse of the function y is equal to f of x is equal to 2 to the x. So sketched there on the right hand side in the green is the exponential function y is 2 to the x with all the coordinates. Now remember, inverse is the swapping of x and y coordinates. So in the place of y is equal to 2x, I wrote x is equal to 2y. Now, let's swap all the coordinates. -3 an eighth becomes an eighth -3. The next one, -2 a quarter becomes a quarter -2. -1/2 becomes half -1. 0, 1 becomes 1, 0, which is a very important coordinate, that one. You will always fill that one in on your graph. And then 1, 2 becomes 2, 1, 2, 4 becomes 4, 2, and 3, 8 becomes 8, 3. And then our graph will look like that. So the green graph was the graph of y is 2 to the x, the exponential graph. And then this blue graph, this one is the inverse. And some things to note here, please, is can you see that the x-intercept was indicated? That's the point 1, 0. And then there is an asymptote here on the y-axis. And then this red line here, this is the line y is equal to x. And we fill that one in since inverse is the reflection about the line y is equal to x. Now, let's work out the equation of the inverse function. Therefore, we have the original function y is equal to 2 to the x. Then inverse is x is equal to 2 to the y, the x and y coordinate swap. And then we're going to write that one in log form. So we write log, the base of the exponent becomes the base of the log. The exponent gets expelled and becomes the subject of the formula, and this x will stand with the log. And then that is in fact your inverse equation. Y is log 2x. Now, is this log a function? How do we test for a function? We use the vertical line test. It cuts it once, therefore, yes, it's a function, and now we can write it in function notation. Let's investigate the inverse of the function y is equal to h of x is equal to half to the x. And there in the purple you can see I gave you the exponential function. And since this base is a fraction, therefore this one is an ascending graph. Now, inverse is swapping of x and y coordinates. Therefore, y is half to the x became x is half to the y. So the first coordinate, -1, 2 will become 2, -1. 0, 1 will become 1, 0. And 1 half will become half 1. And then there's our graph. So the purple one is the original h of x, and this very bright blue one, this is the inverse. And again, this gray line is the line y is equal to x, the line of symmetry. Then, can you see, I filled in the point 1, 0. Very important to add that one. And again, there's an asymptote. Now, let's look at finding the equation of the inverse. The original function was y is half to the x. Inverse is swapping of x and y coordinates. Therefore, x is equal to half y. And then when we write this one in log form, we write log. The base of the exponent is the base of the log. The y will become the subject of the formula, and the x will come and stand with the log. Therefore, this equation of the inverse is y is log half x. Question, is it a function, this inverse? How do we test for a function? We do the vertical line test. So when we do the vertical line test, then we find that it cuts the function, the graph once. Therefore, yes, it is a function. And then now the inverse is h minus 1 x. Let's look at the two graphs now. So the brown graph is the one y is log ax, where, and then this means it reads a is smaller than 1 a is greater than 0. And that means that a is a fraction. Then, on the brown graph, if the base is a fraction, the graph is decreasing. And I think it's very clear, you can see that. Then, on the green graph, we find y is log ax, where a is greater than 1. We can see that. And then, if the base is greater than 1, the graph is increasing. And very important, can you see they cut at the point 1, 0, the axis, and there's an asymptote. Well, the asymptote is there, it's just hidden behind the cloud. Then, please note that the domain is restricted, i.e. x is greater than 0. And then some information. The expression log ax is defined only if. And this means, this reads, a is smaller than 1, a is greater than 0. In other words, a fraction. Or if a is greater than 1. And then a cannot be negative, 0 or 1. And then also for x has to be greater than 0. X cannot be negative or 0. Let's look at an example. If the graph of y is log ax passes through the point a quarter minus 1, show that a is equal to 4. So we start with the equation y is log ax, and then the coordinate here consists of a x and a y. Now we substitute. In y's place we substitute -1, and in x's place we substitute a quarter. Then your very handy tool when you want to solve a logarithmic equation is that you can convert it back to exponential form. And then when you do that, you find a to the -1 is equal to a quarter. And then a quarter you can write as 2 to the -2. And then in your next step, you're going to say divide -1, divide -1. Therefore, a is equal to 4. And then your equation y is log 4x. Let's sketch the graph. So very important here, can you see where it intercepts with the x-axis? There is an asymptote on the y-axis, and then we can write the equation on the graph, log 4x. Remember, you can put arrows and then the x-axis and also the y-axis. 2 is if an increasing or decreasing function. It's an increasing function since there a is greater than 0. 3, give the equation of the asymptote. The asymptote is the y-axis, therefore the equation x is equal to 0. In the next lesson, I will discuss typical exam questions on functions. Click on the video in the left-hand corner to take you straight to the next lesson.